Okay, so let's give you guys some more practice. So here you've got two lines, y equals x squared and y equals minus x to the power 3. Ignore the negative side. So just looking at this bit here, so we are going to use this area here, and we are going to rotate it along the y-axis. So this point here, when you rotate it 360, it will look something like this. And then this point here, rotate it 360 along the y-axis, it will look something like this. But don't forget, it is this area that we're interested in. So when you rotate it 360, you will get a solid looking like this. So on the positive side, you will follow this red line here, the y equals x squared. So it will give you a solid like this. But then on the negative side, you will follow this blue line here. So on the negative side, it's going to give you a solid looking like this. Okay. So on the positive side, you're going to follow the red line here. On the negative side, you're going to follow the blue line, but you will get a solid looking like this. Okay, so you will get a solid looking like this. So what's in the middle here is really thin air. It's just a hole right in here. Okay, and then down here is just a hole, nothing. It's just thin air. The solid is right here. Okay, so work out the volume of this solid here. So you're gonna get like a cylinder but with two holes in the middle here. Okay, and yeah, so you're gonna get two holes. So work out that solid from 0 to 1 here. So work out that solid, and there are several ways of doing this. You can either integrate it by summing up all the cylinders. That's one way, or you can sum up all the washers. That's another way. So this here would be you doing one integral and then you adding it to another integral here from from here you doing this will be -1 to 0, and then from here it will be 0 to 1, or you can use a cylinder, sum up all the cylinders. Well, one way is a lot easier than the other. It's up to you. Work out the volume of the solid. Okay, so work out this work out the volume of this solid here. Okay, so press pause and have a go. Okay, so to do this, I'm going to give you both ways. So let's do these cylinders first. So we're going to sum up all the cylinders. So summing up all the cylinders would be us doing this. When you come to do it, actually imagine doing this from 0 to 1. So you're moving along here. So hang on. So imagine you're summing up all the cylinders here. So if you look at the thickness of one cylinder here, you are summing up from 0 to 1. Okay, so you're summing up from 0 to 1. And let's just look at one particular cylinder, a random one, this one here. There's a thickness associated with this cylinder here. Well, the thickness here is dx. So you're going to have something, and then dx over here. The dx over here. And then if you look at this one particular slice here, when you rotate it 360, it's going to look something like this. Okay, and then 360 is going to look something like this. So your cylinder would look something like this. To work out the volume of this, you would need the circumference here. Well, the circumference would be 2 pi r. Well, this r here would be the distance here, the x distance here. So if you think about it, you are integrating, so you're moving to the right each time. Well, the radius will be as x is moving about, right at this precise point here, the radius is x. So in this case, the circumference is 2 pi x. So that's the circumference, and then we need to times it with the height. The height of this cylinder would be the height. Whoops. The height of this cylinder would be. Hang on. Let me clear this. The height of this cylinder here. Hang on. The height of this cylinder here would be this height, and then add it to this height here. So it would be you getting this, and somehow find a way of getting the total height here. Well, the total height would be given by this. Hang on. So this here would be your circumference. This here would be your height, because the height here, the height at any particular point here, the height here, well, this height here would be x squared, and then from here to here, so normally you would, well, the total height here would be this this plus this here. It does make sense that the total height here would be this plus this. You probably have to think about this, but the total height here would be this plus this, even though there's a negative there, because normally you would have to do this. Normally you would have to get this, which will be x squared, take away this thing here. Well, this thing here would be this. So this thing here, and then blah blah blah. Well, this is your circumference. This is your circumference. This is your height, and you're moving along. So the thickness associated with this would be dx. Well, the volume would be given by this whole thing here. So now it's just a matter of evaluating this. 2 pi is a constant. Remember, we're integrating it with respect to x. So this thing here doesn't really contain x. So let's take it out, and then that will then take you to here, and then tidy it up, blah blah blah. That will then take you to this, and then integrate it, and then blah blah blah. The total area, the total volume will be given by this. In the next video, I'm going to use the what we've done here. So what we've done here is we use the we're summing up all the cylinders. In the next video, we're going to sum up all the washers. Okay. So I will continue in the next video. But for this one here, for this one here, the volume is given by this. Okay. So our method in the next video should give us this answer here. Okay.